Okay, final question. Now, this is really important because we're talking about charge, right? As you may recall, charge is plus and minus. Protons are plus, electrons are minus, and atoms are like little magnets. They got pluses and minuses that stick together, repel each other apart, and this is literally what holds the world together at the atomic scale. So chemists tend to care about charge more than any other thing, right? Some of these are a little trickier than others, but let's look at these first two. First of all, we got Ca and Ca2 plus, and those are two different things. So if we write the 2 plus to the upper right, what you might call a superscript, that's the charge. We say the charge is 2 plus or plus 2. Now, calcium, you notice there's no number there. We get kind of lazy in chemistry. It's as if there were a 0, but we don't write it. So the charge is 0, meaning that it's neutral, right? You're going to have to look up calcium on the periodic table now. It's in group column 2, number 20. So both forms of calcium have 20 protons. Now, we already saw this first problem. Calcium neutral is the exact same thing that we saw back in problem 1, where we looked at neutral calcium having 20 protons and 20 electrons. And the idea there is that it's got 20 pluses, 20 minuses, they all cancel out, or we can think of the protons minus the electrons being equal to the charge. So 20 minus 20 gives us 0, right? You can think of this mathematically. 20 minus what is going to be 2, or the plus 2 means it has 2 more positive charges, 2 more protons than electrons. So what's 2 less than 20? Calcium 2 plus has 20 protons and 18 electrons, and if you want to check out the math, 20 minus 18 is again 2 or positive 2. Now we have a similar thing next with K and K plus. K has 0 charge, K plus. Notice that it says K plus, we mean plus 1. So the charge could be plus, or maybe to put a number on it, plus 1. Now we got to look up K potassium in the periodic table. It's here in column 1. It's number 19, meaning that any form of potassium K has 19 protons. Now, the neutral potassium, again, is the same number of protons and electrons, 19 and 19. K plus means it has 1 more proton, or you can kind of flip the sign on that. If it has plus 1, that means it has 1 less electron. There's sort of a double negative there because it's lost an electron, which is negatively charged. And so K is going to have 19 protons, 18 electrons. Now we have something like iron, iron 2 plus, iron 3 plus. The charges are 0, plus 2, plus 3. And again, we need to go to the periodic table. We already saw this one, iron number 26. So all forms of iron have 26 protons. And the neutral iron has an equal number of pluses and minuses. So 26 protons, 26 electrons. And you might notice that we already did that back in problem 1 if you were following through all the videos. 26 protons, 26 electrons for neutral iron. That's the solid iron metal. Fe2 plus and Fe3 plus are other forms of iron. They might be rusted iron or different type of reactive iron. 2 plus means it has 2 less electrons, so 24. 3 plus is going to have 3 less electrons than protons, 3 less than its neutral state, or 23. Now we have O and O2 minus. Note that charge can be neutral, it can be 0, it can also be a negative number. So we have charges 0 and minus 2 for the oxygen and oxygen 2 minus. We have to look at the periodic table. Oxygen is number 8. There in column 6, it's number 8. So both forms of oxygen have 8 protons. The neutral oxygen, just plain O, has 8 protons, 8 electrons. Now, if it's 2 minus, that means it's gained a couple of electrons because it has more minus charges. You can think of it as 2 more minuses than pluses. So the number of electrons has to be bigger than the number of protons. That's kind of the opposite of what we saw with the plus charge versus the minus charge. So 2 more electrons, 2 more negatives than positives. We have 8 protons, 10 electrons. And if you happen to like math, right, that rule still applies that the charge is the protons minus the electrons. 8 minus 10 is indeed equal to minus 2. So last two here, we have N3 minus and P3 minus. They both have a charge of minus 3 as it happens. They're right beside each other in the periodic table. They're both in column 5 for what it's worth, just to help you finding them. But that column number has nothing to do with this problem. We want to know the protons. So nitrogen is number 7, P is number 15. So I'll just write that down. 7 for nitrogen, 15 for P. And now we've gained 3 negative charges, 3 more electrons than protons. So 7, it's minus, but we're going to add 3. Just think and do the opposite. 7 plus 3 gives us 10 electrons for nitrogen, and 15 plus 3 gives us 18 electrons for P3 minus. And I should say that's not nitrogen, but N3 minus. N and N3 minus are very different things. And if you only learned one thing in this assignment, right, at least know that when you have something that's neutral, no charge written, versus a charge written, those are 2 different forms of the elements. They are very, very, very different things. For example, O in its neutral form is in the oxygen in the air you're breathing. O2 minus, that tends to be present in the rocks, the solid stuff that are in the earth underneath your feet. So 2 different things, just a little difference in notation with the 2 minus, but they are very, very different. 2 different forms of the element oxygen, and this is going to be true for all the elements. They all have different forms, whether they could be neutral or charged.